So, welcome to the Veritas Automata Truth and Automation Deep Dive, our podcast. I've got Saurabh here with me. I'm Ben Savage, the CEO. We've got Saurabh, our senior scientist, or our principal scientist. So, we're going to start today off talking a little bit about some of the news we've seen in AI today. And then we're going to get into a little bit different topic. We've been going really deep recently on Gen AI and machine learning, or Gen AI in particular. And we're going to go back into conventional machine learning for a little bit and talk about some of what we've done and just how some of that's advanced in the last couple of years. So from a news perspective, like you were just sharing a story with me while we were waiting about Humane.
Yeah.
And so why don't you tell me a little bit about that?
So I just saw a news blurb that, Human finally went out of business. It was bought by HP for around 120 or 119 million dollars. Again, it was an interesting idea. As we were talking that
Yep.
it had some issues with the hardware not catching up with the latest LLM models, because the aim for Humane was to have the AI sit on your locally run
Yeah.
on it, and the models. I think when they were kind of peaking with their business model coming out of the market, none of the distilled models were good enough compared to what it is today. But again, fitting a large language model on a very small footprint is always going to be a challenge.
Or having to deal with comms to go get
Yeah.
it. But I think the idea of what they were trying to do of have that really easy to work with AI assistant,
Yeah.
if I remember right, they started like 2018 or something. They've been around for a while.
Right.
And when you look at the stories around Humane, because the assets were acquired by HP,
Mm-hmm.
they're buying it not for that little Humane piece of hardware, but for the potential to interact with those
Correct.
as like those personal agents.
Yeah.
I think that is a trend we've seen, right? You've seen whether it's Humane talking about it or Rabbit with their large action model, I think that's what they call theirs,
Right.
or just Apple and Amazon talking about how to make Alexa and Siri smarter by using the goodness of the LLM interface.
Right.
But I think the key is what you were talking about is that you can't always do this with the super large parameter models because that
Correct.
creates some challenges.
Yeah, I mean, we have always talked about in the past in this podcast about having specific large language model for specific things. If you think about what with a personal assistant on your lap or on a phone, it has to
Yep.
go through voice to text first, and then use the text to run an LLM, and then convert the text back to speech often, right? So there are
Speech or an action, right?
or
If you're
speech
telling
or
it to
an
go open an
action
app
or
or something.
something like that, right? So it involves quite a bit of test, pipeline and compute. Maybe possibly pushing some of that to at a hardware level that is hard coded and not running through conventional CPU kind of a setup might help out. It's a cool idea for sure, but again, it needs a little bit more development, I would say, in distilling it in a way that it knows really well about certain things and can answer 90% of your questions and not answer a question from quantum physics. Or it does a lookup on the
Yep.
Google. It has the capability to go make an API call and pull up the latest information rather than relying on its memory bank.
Yeah, I will say, Perplexity just announced their deep research, and there's a couple others. I think Gemini has a version and OpenAI has one.
Right.
I don't know if you played with those, but you and I tried to build some
Yes.
agents a couple years ago,
Yeah.
or I guess about 18 months ago, and we
Yes.
found out they made a lot of stuff up. And
Yeah.
so far with these, I've been really impressed.
Yes, I mean, the world has moved quite a bit on, the reasoning piece of it. I think it's taking the center stage more and more. Mira, who was the former CTO of OpenAI, started another company. It's called Thinking Labs or something.
Thinking labs or thinking machines.
Thinking machines or something like that. So you can see the trend move towards more and more focus on not just input and output, but have intermediate thinking processes built into the LLM to be more useful, right?
Well,
So-
and it's not just the thinking process. The challenge with a lot of the early LLMs is they weren't connected with, I'm going to use the term a crawler, right? So they didn't have access to data beyond what they were trained with.
Right.
So they didn't have, first step was creating tool use. And then that enables you to use a crawler so you can now go crawl the web. Now that creates a whole other challenge. And we think about this, and I know I've got my marketing team on it. So it's like, what does this mean from a marketing perspective? If you're not using Google for that, where so much of that SEO is, and now it's going through other web crawlers and other things, what does that mean?
Right.
That'll be an
It's
interesting.
going to be interesting because a lot of, personally, I have moved quite a bit of my search from Google to, other LLMs where they're digging into, it may not be the latest, greatest information like Google does, but it does capture the essence of what I'm trying to do. maybe a new version of search engine will come around, which is not just keyword search, but using some of the LLM goodness to find the
Well,
intended
and there's a difference in the tech on how it works, but remember, like what Google did was they brought in this whole advertising scheme where they can
Right.
go sell ads. That's
Yes.
one of the complaints people have had about Google more recently is it's got so many ads in it.
Right.
So you go use these other tools. So what does that mean for all the people who spend on their advertising budget now?
Correct. I mean, yeah, absolutely right. So maybe the advertisement will come into LLMs. Who knows? We don't want that, but
Yeah,
that,
the LLM is trying to subliminally market you. You need
yeah,
this.
recommending products maybe or tools. Who knows? Maybe there's a play there, but I don't want it to be that. But uh, that's where the world is kind of slowly
Yeah.
gyrating towards, right? Towards getting to more of an LLM power rather than keyword search.
But I think back to thinking machines
Yeah.
and what they're doing, one of what they've talked about is doing open source. And I think it's really interesting when companies do that to see how people take that and apply it in different ways. DeepSeek is an example of that, right?
Yeah.
They took some of the Llama model and some of the Quen and they did their own training and found ways to enhance it,
Right.
which creates some interesting opportunities. I've seen the same thing happening from the image and the video generation.
Right.
There's that model Hanyon, which you and I've looked at a couple times. And there's just a new version that came out, Skylark, that came out yesterday, which is a much faster version where they've enhanced it, they've trained it, they've split it. Because you and I were trying to get it to run on dual video cards, and this group has figured out how to do that. And it's interesting to see how that pushes, because that drives the commercial tools to figure out, okay, if these guys are doing it open source, how do we do this in the next phase?
Yeah, I think hallucination would still stay there for the creativity part of it. Like you are using video generation, that's pure creativity, not factual lookup or anything. It still has a lot of the physics, real world physics built in. How a llama looks in a video, that has to be still held true. But beyond that, it's the gentle or the mix of reality and the piece of where it's coming up with the new ideas is going to be key in worlds like
Well,
this.
and you mentioned the hallucination. I'm not sure you can really bake that out of the models proper. I think that's going to be stuff you have to put in around it. Otherwise, you end up, let me rephrase that. If you have a very specific model and a very specific data set, then I agree. You can probably bake out most of it at the model level. But by the time you're trying to get something large, I think you're going to have guardrails. And those guardrails are challenging, as we were fighting this morning. Things that aren't supposed to sing and all of a sudden do poetry.
Yeah, I mean, if you think about LLM and this whole family of model are not designed to be predictive from ground up, whereas the traditional models were. If you want to decline on your credit card transaction, you need to know exact rules, and because it could be somebody in an emergency situation want a repeatable behavior from their credit card, right? It's not like, hey, I bought a baby milk from this store yesterday, let me, but today it's not letting me buy it, and it's middle of night, and so the LLMs probably don't fit the bill there for those purposes. You need very concrete traditional models which behave predictably. So
well, and that's there was an article you and I were sharing that LLMs and a lot of the generative AI is much more like quantum physics than it is conventional statistics, right? It's all about probability. But back to the conventional machine learning and the predictability and determinism of it. You and I've spent, we were just looking at demos back to 2017, 2016, doing a lot of stuff with image recognition for all kinds of different solutions, whether it's on video or image. So let's talk about how that piece of conventional machine learning has evolved. Because when we started, it was like OpenCV was the peak. And maybe you were doing an item or a pattern recognition, but more likely we had to do chroma keying and all kinds of stuff.
So we started off that path of recognizing stuff in images for that project you're referring to. We started off with chroma keying and identifying patterns and all of that stuff. It worked really well when we were training it and we were kind of doing it in the lab. But as soon as we took it out in the world, where the lighting situation changes, the environment changes, it starts to fail. That's when we brought in the neural network based ones. It's still it's not a probabilistic model. It still goes through weights and biases and multiplication and all that stuff. So it's still predictable, and it did really well. And because it generalizes really well, because you can create millions of pictures and artificially create variations among them and move them, rotate them
And that's one of
noise.
the crossovers with generative
Yep.
AI too. That's where we were starting to mess with
Yep.
GANs, generative adversarial networks,
Right.
and say, okay, here's a good set of data, so let's generate some training and build that into the neural network.
Correct. That helped quite a bit on creating that all possible scenarios for that neural network to learn generalized stuff, right? Um, and we deployed it. It works
Yep.
really well across multiple different, on the edge. Actually, it wasn't
Well, and
when.
that's the benefit of
Yeah.
something like that, right? You can make that model really, really small. I think
Correct.
we figured out the entire neural network for that's a couple hundred K, right?
Yeah, yeah, it's literally,
So,
I think it was like 500 KB
yeah.
or something small like that. It was super tiny, but remarkably, it has been resilient across the years now, across multiple different,
Well, we've continued to enhance it, right?
yeah,
That's the benefit of a model like that. You can control
hmm
when it gets updated, how it gets updated, so
yeah,
that you know you're maintaining that predictability. So
correct.
we update that model for that particular customer probably 4 times a year.
Yeah, yeah,
We get some additional data in of both good and bad scenarios, and we go update that
yeah.
so that we can continue to enhance it.
hmm
And then right now we're working with them and say, okay, how far out to the edge can we really push this? Is this on some kind of server at the edge, or can we push it all the way out to the actual sensors that are image sensors and push it all the way out? And in the last probably 4 or 5 years, there have been enough advancements in microprocessor and embedded technology. You can do that on very inexpensive systems, like an ESP32 for those of you who are, or ESP32S3 you probably want. If you're getting into the hardware world, or to a Raspberry Pi, which is a little bit more expensive. And that's really cool. When we started doing this project, you couldn't push that far out to
Yes,
the edge.
yeah, yeah. I mean, that's the beauty of it. It's pushing it out to the edge. You have to be very, very purpose built, right? And then you have to really trim the fat and not throw more and more neurals at it to
Yep.
make the layers deeper to capture more of the variation.
So, but
Yeah,
let's go to a little more of the history, because
yeah,
we mentioned we started with OpenCV, and there we
right.
were really doing object detection,
Correct. Yeah,
and we were doing that by chroma keying and extracting the object from the background,
yeah,
which was cool, but it was very resource intensive, right?
right,
It required a lot of compute, required a lot of memory, required a lot of time to go do it, to make it responsive.
right.
And then it was kind of sensitive to different lighting conditions. So
Yeah,
then we moved to what you were describing, that neural network
yeah,
approach. And when we did that, we found out some other benefits too. Like we can train the neural network to be different around the edges of the image that we're detecting
right.
versus the actual core of the image, which
Yeah.
gives us a lot more accuracy in how we're going to go measure it if something gets moved
Yeah,
around.
I think that was a very, very cool piece of innovation when we solved that problem, because we were using heavy fisheye lenses, so the things that we were detecting looked different at the
Yeah.
edges versus in the middle, right? So yeah, and the good thing about it is that I think we changed suppliers in the middle a couple of times with the lenses and the camera, and it was still resilient. We had to train it, but
Yeah,
you could,
the core algorithm was resilient,
yeah,
but by updating the data in the model
yeah,
and updating that neural network, we could push a new version down without changing the rest of our solution. We could go
exactly.
deal with
Yeah.
additional lens variations or other
And
things.
it was able to support the legacy cameras, or
Yeah.
it's a machine, and as well as the new stuff. So that was pretty cool to work on at that time, because neural networks historically I've worked in bigger banks and all that stuff. They were kind of going to a central server, and then all the requests come to one place, or one of those big compute one, versus this is where we are sending it to edge for for a very fast
Yeah.
reaction time, and you are not dependent on network
Yep.
or anything like that, right? So that was a very, very cool application of neural network at edge. So,
But then as we've continued to look at that, we've been
yeah,
looking at some of the newer algorithms, and we kind of studied the YOLO family of
yeah,
algorithms. And
mhm.
it's, you'll have to correct me on this because I always mess it up. I think it's YOLO 1 through 4 are
I think
open
1 to
source.
3 is
1 to 3 are
source.
open source, and
Yeah,
then 4 and above
yeah,
are like a business source license, or
correct.
there's a commercial license
Right,
required.
right. Yeah, YOLO is a bit more involved, but it's still pretty real time.
Yep.
It's able to detect various classes of images, what's in your image, and put a bounding box around it. That's the original YOLO setup. It was supposed to. It really ran on real time, and you could
Yep.
run it on a Raspberry Pi. You would get a couple of frames per second in terms of inference, and as you scale up your hardware, it gets more and more real time. I think some of the latest YOLO version, they support more than a bounding box,
Yep.
which is a box around the image you're trying to detect, but rather the pixel level. You to highlight that whole area where it's at. And if you have humans in it, it can do pose estimation. That is where your head looking at, or your arms and legs are. Think of an application, say in a shopping mall. You can trace where are the people who is walking through the pavilion looking at, right? So you can put ads in the right strategic ways and things like that. So it become more and more useful.
Well, and that takes me back to a project that you and I did or just as like, it might have been in early 2020, actually.
Right.
But it was based off a unique display that Delta was using in a couple of their lounges where based on a user's position, it could show a user, that specific individual, their flight.
Right.
And the way it worked was you would go scan on a kiosk and then the cameras in the facility would track you. And the reason we were working with that is we've been doing some work with biometrics, but had some applications where we need a biometric-like approach, but without biometrics, meaning we weren't saving that specific individual. And so we were looking at that and something like the pose estimation, because I don't remember exactly how we made that work. I think were we using pose or were we just using bounding boxes?
We were using depth camera
Yep.
to kind of get, because one of the things we kind of ran into is what if I hold a picture up and, lively
Well,
let's
that was the facial recognition. This wasn't the facial
Okay.
recognition. This is where we were scanning and we had the camera mounted above and we were tracking in the room so
Yep.
that we knew once you identified, we could track an ID number,
okay.
not you as a biometric.
Yeah, so I think that was more on tracking. So, you would run a YOLO and identify this person, you give it an ID, but across the different frames, different camera, you would look at whatever the defining characteristics of that person is and track them. Even if there are multiple people, you would be individually be tracking. So let's say you as Ben go up to a counter and then authenticate yourself, that ID becomes authenticated. And as you walk through the facility, we know who you are. You have been authenticated. If you reach a zone where we need to open a door, we already know you're authenticated. We'll let them go in. I think we were just scratching the surface. It could have been easily extended into gait recognition and all of that stuff, and occlusion, all of that could come into it as well.
Well, and I think the cool way about the way we approached that one was we weren't retaining any of the data, right? We just knew that we didn't know that individual that we were tracking the bounding box around that pose or that person. We didn't know that was Saurabh. We just knew that was
XYZ or whatever, right?
What it was, and then the data went away after that. So for some states that we were dealing with, it helped us deal with some biometric laws that we had to we're trying to avoid.
Yeah, I think you're right. This was pretty different how we manage data versus a facial recognition where you would store and then you come up. This was more like a transient. These are my characteristics of the person I'm tracking. As soon as they are out of whatever the facility, we just dispose of them. And it would go away, kind of a setup. But that was another cool thing that we did.
Yeah, I remember when we were building the facial recognition system, we probably were halfway through and like starting to test just as that paper came out on bias in those algorithms. And we kind of ran into that in our own way, but not the way those papers did. Because the papers we're talking about particularly that most of those models are built by labs of people of tended to be white Americans or Chinese were the main labs that those were coming out of. And some of those models were not 100% accurate, but it meant that they weren't accurately working on people from other races. And we were doing some testing and we saw that, so we started bringing in. Our challenge was we actually had a fairly diverse team, and what it was doing was mixing up myself and someone who looked fairly similar to me. And it could not tell us apart for the life of us when we first started, and we continued to add data and enhance it. That's one of the things when you work with algorithms, right? You got to think about how are you preventing bias in the training and the development of the algorithm, as well as making sure that you test it so that you know it's going to work in those scenarios, so you don't find a bad edge case out in the field.
Yeah, unintended bias in models is a common phenomenon because.
And sometimes that's referred to as overfitting, right?
Beyond overfitting, overfitting is like if you say you have X class of data and Y class of data, they are so overfitted, little bit variation of X, you don't be able to detect it. But from the start, you've never seen Z kind of data in it. You don't know about it. It wouldn't, it would be like, hey, I don't know what this is. And that's what you're kind of referring to, is that it creates a bias that, hey, Z now belongs to X. It's not its own thing, right? So setting up the data becomes very critical. And, like we say in the data science world, 90% of the work is getting the data set ready, cleaning it, making sure it's free of biases and all that stuff before we kind of proceed.
So, we were talking about the YOLO set of models, and that's really evolved from when you first worked with it in like YOLO Original 1 to all the way to, I think it's up to 10
11
now.
or 13 now.
13. And there's some variations where people have done some customizations to optimize it for different things. That's come a long way. But then, what was it, 2 years ago, Facebook introduced Segment Anything?
Yes.
Or was it 18 months ago?
Yes.
So how does that change image recognition?
So YOLO, traditionally, you would have a human do the annotation, which is basically, if it's a bounding box, put a bounding box, and then call it out what it is. So it was a very labor-intensive process, right? So
And let's talk about what an annotation is. 'Cause I think if you've not worked with building a
right.
machine learning data set, that's a very important piece of it for building those
Yeah,
algorithms.
so let's say you have an image, right? And the computer's looking at it, or the algorithm's looking at it. It's just pixels of data, 3 RGB color, XYZ coordinates, it's right there. But where within that picture does your object that you are trying to detect lie? It doesn't know. So when you annotate it, what you are putting is basically saying that from starting from X and Y coordinate to X2, Y2 coordinate, this is what my an object is in there, and this belongs to XYZ class or whatnot. That's the annotation. So it could be a bounding box, and or else you could go down to pixel level and paint over it, saying that this is my object I'm trying to
And that's
detect.
traditionally done by people in a lot of
Correct.
cases, right? That's where like Amazon Mechanical Turk comes in,
Yeah.
or outsourcing to different parts of the world where
Right.
you've got just people going through thousands and hundreds of
Yeah.
thousands of images,
Yeah.
annotating them to mark them for the data set.
And there was a popular joke that humans are bootloaders for the AI, and that's probably where it came from. we had,
Don't encourage Terminator. We don't need Skynet. Don't encourage it.
yeah. So going back to the annotation, it is also true for, like a financial data or something like
Yep.
that, where you would have gone through, let's say, loan applications, and then which loan application defaulted or stuff like
Yep.
that. Again, it's not humanly done, but again, you are collecting that data and marking it 0 and 1 kind of a flag. So basically training,
Yeah,
basically,
you're either saying this is good behavior that we want, or this is bad behavior we want it to avoid.
correct. Yeah.
So that way, when the model learns, it's going, okay, depending on which way you're optimizing it. If you're fraud, you're teaching it this is what fraud looks like. We don't want to see this.
Yeah. So basically, acting as a teacher who's building out a question set as well as the answer for the AI to kind of go through and learn it. So with the segment anything, it was a pretty cool moment where you could click on an image. If let's say you're clicking on a ball, and it will automatically put that area around it, saying this is my ball, or this is a human being, or or a dog, or a chair, or something like that. So you could segment that really, really quickly without having to paint over every area within that. So it accelerated the whole process of annotation quite heavily and quite quickly. And that was a cool tool from Meta, because I think they were able to identify from the image itself what are the different objects, even if they're overlapped, how they are segregating that. That helped on annotation side quite a bit as well. So
Well, and they've got two versions, and that's important, right?
yeah.
Because as you think about some of this, there are ways to combine conventional machine learning and generative AI for like things like the annotation to be able to build those descriptions and things so you can enhance the algorithm.
Yeah, I think with the some of the vision capability coming to large language model, you're starting to see you can upload an image and say what is in there, or something in those lines, right? So you're trying to see that overlap start to happen slowly. It's gonna take a little bit longer, and you won't be able to find defect on an iPhone screen when it's being produced on the supply chain. Um, but it is slowly getting there. I think you shared a paper around fraud in financial world LLM being used, right?
Yeah.
So I was kind of referring, hey, yeah, the examples they had on the paper kind of made sense, that why are you doing at 4 o'clock in the night? But some of that has already been solved using traditional models, right? Because you would pick up patterns and build that up over the time, and have it in a repeatable fashion, right? So that it's not going through a probabilistic model down the line. So
So here's a question with that, because one of the things you and I've talked about in the past, for most machine learning problems, you do have the cold start issue.
yes.
So the cold start issue is, okay, I want to start whether it's for fraud detection or conventional data analysis or for image recognition. I may not have that library of thousands of
Yeah.
annotated images. So how do I start?
Yes.
Does using the LLM in that case maybe help?
Absolutely. I think
the
that
cold
makes
start problem?
quite a, it can act as a seed, because it's learned over over a much larger corpus to
Yeah.
create a synthetic data set, right? Prior to LLMs, we were using GANs to do that, to replicate. So the structure of GANs is there are two neural network fighting. One is trying to decipher whether the data is real or synthetic, and the other's job is to just create synthetic data that looks like real. The goal is to be good at detecting the difference between the other one is to mimic the real data and pass as a as a real data, right? So over this, you would feed it with a little bit of a data. Like, let's say you collected data on a machine vibration on a motor or whatever, and feed it to it, and after training for a while, it would be able to replicate a motor vibration data very close to what the real data would look like. Instead of having, say, like 10 minutes worth of data, you can have hours and a day's worth of data. So more data means a better neural network,
Yeah.
fitting down the line to detect abnormalities and defects and all of that stuff. So I think GANs took off really well around that. There were come other toolings to find synthetic data. LLM does something very similar as well. You can ask it to generate a lot of reasoning process or text data, or even let's say you are training on tickets for IT services and you want to classify that this is severity. Let's say a hypothetical
Yeah.
case on severity. You want to build a model which can classify tickets on severity, right? Real severity, not what the users is saying, but based on what the symptoms are written in the ticket and kind of flag them on different things. To create that corpus, you can have the LLM generate a lot of variations and
So here's the question: if you use an LM to do that, how do you make sure that data is valid for the testing?
you won't, because this is again, if you're completely automating the
Yeah.
pipeline, right? So you want something what you refer to a cold start, get the thing rolling and see how it's performing, and then you get an human involved saying that okay, LLM decide generated this ticket and also classified as high severity, but it's truly medium, and then start to bring your historical data into it as well. So, there are ways where you can prompt engineers and say that, hey, traditionally my tickets look like these. These are examples for high severity, medium severity, and low severity. Create something very similar, but not the same. So it starts to get on and understand your business quite a bit. So we always come back to the same thing. You cannot throw stuff at LLM and expect it to work. You
Yeah.
got to build a pipeline around it. It's a cool tool. It looks like it's super intelligent and can do stuff, but you still need to guide it for it needs to be, because underneath is probabilistic model,
So
right?
let's go back to conventional machine learning,
Yes.
which is kind of where we were.
Right.
It's fun to get into the Gen AI because
Yeah.
there's just so much cool stuff. But we had talked about the YOLO and segment anything. What are some of the other new advances you've seen in that space that have
Image processing.
image processing or just general pattern recognition?
So in pattern, this is not a new tool. XGBoost has been there for a while. It's a gradient boosted method. A lot of those kind of traditional tool, the trick is on the hyperparameters, which is you gotta tweak multiple different parameters. These are statistical models, so you're controlling different learning rate, variance, all that
Yeah.
stuff to control, and often they would have multiple different.
So when you say learning rate, this is meaning how is it continually adjusted and
Correct. Yeah.
increase its learning as it gets new data in?
More like if you make a mistake, how would you account for that? How
Gotcha.
much would you move your weights to account for that? If your learning rate is really high, the parameters tend to shift around quite a bit, and you never get a stable model. But if you keep it too low, it doesn't learn much either. So there's a sweet spot, and it's very dependent on the data, the depth of the trees as well, or how many samples you want on the leaf node. So think of this is not a simple decision tree. XGBoost is more like a forest of trees, kind of like. So there's you cannot manually inspect every other tree, right? So training the hyperparameters, I've seen that getting more and more automated. Large part of my job when I was building those back probably 5 6 years ago, it was tuning them just to make sure when you train them, the matrix from the model kind of matches your auto sample or validation, which the model has never seen.
Yeah.
They need to be very similar, or else you would call it overfitted or underfitted or wherever. You want them to as close as possible. So automating that, I think that has come a long way around around those traditional models,
Yeah.
because that's where the art piece of the data science lies, is how do you kind of tune them, and selection of model parameters as well. So
How can it be art if it's science?
well, it's a balance between it. It's called data science, but yeah, you have a statistical method around a lot
Yeah.
of those things, but there's the piece of art around the parameters that we cannot have there are very few heuristic rules around how to select those parameters. Uh, there are some, but they don't always work.
Well,
So
and it's really data set specific. It's
yes.
what is what is the business goal you're trying to achieve, and what is the data you have to go achieve
Correct.
with.
And every data set is different. It could be completely imbalanced, or it could be very balanced data set. And those impact the models quite heavily. And knowing, with traditional model, you really can't throw stuff and expect it to stick, which you have seen quite a bit on Gen AI side. You throw stuff, you get something reasonable out of it. With traditional, you gotta know the algorithms, the stats, and what do the parameter mean to kind of get to the answer quickly, or else you are guessing those parameters most of the time.
So one of the things I know in the past people were doing was using more conventional machine learning models for, um, so think about it like where you've got content moderation,
Right.
right? Whether it's for image-based or for what people were doing,
Right.
they were training models on, these are bad words, these are good words, or usually it's bad words, or
Yeah.
this is abusive speech, or whatever that is. And I've seen people starting to try and use LLMs for that. So how do you think about that approach, right? Because it's challenging. Humans are really good at finding different ways to say stuff.
Yeah. Um, it also depends on how much I think the main emphasis is because with traditional model you have to constantly update the data sets as they come up with new slangs and bad words and bad ways of representing thing which was good. So you gotta constantly maintain. It's like an antivirus. You
Yeah.
gotta push updates and updates out there. With LLM, people are hoping that some of the common sense ones you don't have to train it, and then only push the ones that are a very specialty thing. So if I were to use certain setup like that, I would have like a multi-tier approach. Have the LLM do it, and then if it is shaky, not just say yes or no, but also say a maybe kind of thing. I'm not fishy, and run it through your traditional tools as well at the same time, and reach a consensus. So not just AI, but AI and traditional
Yeah.
ML coming to a agreement saying that this is to be flagged or not to be flagged is probably the way to go. It can't be one or the other. It's just the way of the world.
Yeah, that I think is going to be interesting. And then you and I've talked about, because there was a problem, it's kind of related to that actually. In the industrial space, you get parts catalogs, and you may have or you go in someone's ERP and they may have the same the same item with multiple part numbers, the manufacturer part number, 3 or 4 vendor part numbers, an internal part number. Maybe there's some kind of name. And we've seen the same thing in life science, from the chemical composition of a pharmaceutical to the brand name to different variations of similar compoundings. Um, I think that's one of the things that we found. There are conventional machine learning approaches, but you kind of run into a cold start issue. But large language models are actually interesting for that one.
Yeah, I mean, if you think about it, yeah, they don't have cold start on a large language model, but you still have to hand it a corpus of what different acronyms are of the same chemical name, right? So it's kind of doing a lookup, but you gotta provide it with the right stuff as well for it to work. Sure.
One day we'll take the meta glasses and we'll build in an automatic acronym
Yeah.
translator, so as we're in different environments.
Yeah, that would be cool.
So, any parting words on large language or on conventional machine learning and image detection or anything?
So I would say that in the world of the buzzwords of AI and everything, it's getting the backseat, but large practical applications are still on traditional machine learning models because you want certainty in your business processes, and if you're doing detection, it needs to be repeatable, and that's where a lot of these traditional models are still going to be existing, right? So
Yeah.
maybe in future, what's going to happen when a problem comes in, LLM decides which tool to use, and those tools could be traditional machine learning models, so that it's not guessing it goes through a repeatable process, but that picking process of what tool to use could be automated, and a layer of automation can be built in.
Cool. Yeah, I think my experience with it is I think people sometimes underestimate the amount of data they have. And I remember some of the image things
Right.
that we were working with where we're looking at it as humans. We're looking at it as here is a color image. Well, really, you've got multiple channels of data in there you can use in different ways. And we find that with other sources too. If you're looking at files or text information, you've got metadata that goes around it. You've got all kinds of other stuff you can use to build those models, if you step back and think about it. And that can be ways to help make your detection more precise and more accurate.
Correct. I mean, this could be an overstretch, but English language, as you have heard it before, it's a low bandwidth. You are compacting a lot of information, and trying to kind of, you know that these are the common sense things, you understand that. But whereas if you're dealing with traditional model, it's all out there. There's no assumptions happening anymore. That's the data, right? So that just pushing everything through a language model may not be the right way to do it, but having it like, hey, go look at the real data, which is the traditional model does, might be a better way when you're trying to predict something really accurately.
Cool. Well, we thank everyone for joining us. We'll see you on our next podcast in a couple weeks, or in a week and a half, I guess, 2 weeks, whatever it is. This is why I'm let everyone else make sure the schedule's there so I don't get confused. But we appreciate you joining, and keep dropping the questions in. Put them on our LinkedIn or on YouTube or wherever you're watching us, and we'll try and answer them and keep the content going. So thanks, everyone.
Thanks.